All right, what's going on, y'all? Hope you scored well on your quiz this morning. We'll be sure to go over those tomorrow. But for the notes tonight, you should have grabbed a note sheet after your quiz. And we're talking about graphing systems of inequalities. Now, we're combining what we know about graphing inequalities and what we know about systems of equations, and we're putting the idea into one. So let's do a warm-up and kind of remind ourselves of what we know already. All right, graph the inequality on the coordinate plane. So it's already in slope-intercept form, y equals mx plus b, with b, your starting point, being positive 5, and then apply your slope from there, rise over run. So up 3 over 4. We could also go down 3 to the left 4. Now, when we go to draw my line, we need to have a dotted line, because it's less than. Remember, it's solid if it's less than or equal to. Oh, and I drew a solid line. So it's a dashed line, okay? And we're talking about less than, so I would shade below my line so that every solution within the shaded region works. Again, you can always test your solution. A good one to test is 0, 0. So if x is 0 and y is 0, is 0 less than 5? Sure is. So it checks out. Again, you can always check your solution. Now in part B here, it says graph the inequality on a number line. Now these ones we did way back at the beginning. And x is greater than or equal to negative 4, and negative 2 times x is less than 10. So this one's already solved. This one we need to divide by negative 2. Now remember, when dealing with inequalities, whenever you multiply or divide by negative, you have to flip the sign. So we flip the sign there. All right, keep in mind it is an and inequality, so we're focused on everything that's shared. So we have negative 5 and negative 4. X is greater than or equal to negative 4, so we have a closed dot heading to the left. Nope, my apologies. Closed dot heading to the right, because we're talking about greater than, so the numbers are getting larger. For x is greater than 5, we have an open dot heading to the right also, because the numbers are getting larger. And remember, it's everything that is shared. So my solution is going to be a closed dot over negative 4 heading in the right. So all numbers larger than negative 4, or actually greater than or equal to negative 4, would satisfy this inequality. All right, and then the last piece is what we've been doing this chapter, graphing the system of equations in order to find the solution. So where the graphs cross. So let's graph this first one here in blue. And it's already in slope-intercept form for me. So my starting point's negative 1. From there I go down 3 over 2. Down 3 over 2. And I'm going to put as many points of interest as I can. And there's my line. Now this one, it is not in slope-intercept form, so we have to manipulate it first. So let's subtract our 4x. So I have negative 2y equals negative 4x plus 12. Divide everything by negative 2. And I'm left with y equals positive 2x minus 6. All right, so now let's graph that. We have negative 6, and from there we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. No, because we haven't hit it perfect. All right, now, so this is my point of intersection, the red dot there. It's not very pretty. All right, it doesn't look like we have a nice whole number answer, so when that occurs, remember we go to our trusty calculator. Let me make sure I can get it here. All right. So my first line, we go to y equals. All right, and my first line there is y equals negative 3/2 x minus 1. Let's minimize this here. So negative parentheses 3 divided by 2 times x minus 1. Then in y2 we're going to put the one we solved for, 2x minus 6. Let's graph it. Okay, right there the window looks appropriate. So now we go second trace to our calculate menu, and we're looking at number 5. We want to calculate the intersection. Little Spidey pops up. We hit enter on that curve or that line, hit enter on that line. No need to guess, and we get 1.43 comma negative 3.14. So 1.43 comma, what was that last number? Negative 3.14. How I didn't know that. And that's our solution to our system of equations. So now in the next example here, we're going to combine these two ideas from part A and part B. Okay, we're going to find the solution to a system of inequalities. All right, you ready for all this noise? Let's do it. So, graphing systems of inequalities. All right, it combines all three concepts that we just did in the warm-up. So, remember, we graph inequalities just as we normally do, but we also need to pay attention to whether it's a dashed or solid line. So, my starting point's negative 4. And from there, up 1 over 3. Up 1 over 3. Up 1 over 3. Now I'm going to go down 1 over 3. Now it's a dashed line. And we are shading everything above. So we're shading everything above. Now, one thing to keep in mind is, remember, inequality has multiple solutions. All right? Anything that falls within this yellow piece here, that is a solution to the inequality. It'll satisfy that equation. So there are multiple answers. So when we're solving a system of inequalities, we're not going to have one intersection point like we do when we have a system. We're going to have a multiple points. So let's do the next line in red, let's say. Again, nice and already in slope-intercept form for us. So this time my starting point is positive 3. And from here I'm going to go down 2 over 1. Down 2 over 1. Again, we're not as concerned with the intersection point. If these were both equations, I would be. Then up 2 over 1. Now this is a solid line because we're less than or equal to, that equal to piece. And now we're less than this line. So we're focused on everything that is below this line. So it says, name any 3 points that satisfy the system of inequalities. The solution to this inequality is actually everywhere where these two lines overlap. Let me see if I can get darker color in here. There we go. Everywhere where these two lines overlap. So everything within that shaded piece there, where the green and yellow cross. So name any 3 points that satisfy this. Well, let's pick some. Let's say, sorry, I'm just trying to get this a little more focused. Let's do 0, 0, the easiest one. 0, 0 would work. Negative 10, 0, which would be right at the end of my intercept here. All right. Or let's say negative 7, 7 would be right in there somewhere. That would also be. So down here it asks us a few questions. Is the point negative 5, 3 a solution? All right, well, I'm going to get rid of this for a second here. And remember we said everything was shared in here. So that was my solution. So is negative 5, 3 a solution? Negative 5, 3. Does it fall within my shaded area? Yep, it's inside that shaded region. So we would say yes. Inside the region. It says, what about 1, 1? Is 1, 1 a solution? Well, it falls right on my line, so yes, because it flies on the solid line. Now the solid line is the key part. All right, if it was a dashed line, it would not be a solution. So for instance, let's look at 3, negative 3. Now this is a very, very important point here. 3, negative 3. This is the point at where both of my lines crossed. Now, you have to be careful here because this satisfies negative 2x plus 3 because it's a solid line that lies on that line. However, does it satisfy my other equation? And that is no. Because it's part of that one. However, it does not satisfy this one. All right, because that's a dotted line and the solutions on that line do not satisfy that equation. All right, if you're confused, you can always test it algebraically. But if it falls on a dotted line, no, that is not a solution because in order to satisfy the system, it's got to satisfy both. All right, so on your quiz or test, if I asked you to shade this, you would shade above this one, okay, below this one, and since your color's only the same pencil, we would just try to shade this a little darker. Okay, and once we get good at it, we'll just be focused on shading the solutions. So tomorrow in class, we'll do some more difficult examples, see where this applies to real life, and solve some problems in our groups. All right, enjoy your night.